Hey folks, Quill18 here, and welcome to another episode of our Unity tutorial series codenamed Project SpaceCube. The last episodes, I don't know exactly at this point how it's going to be cut, dealt with, was a live stream thing, and we added camera controls, we added more user interface stuff, and including what we did is we set up, say, our thrusters, they actually respond to the space bar. If we hold it down, they will fire, although we have to turn kinematic. This whole ship has one rigid body, normally set to kinematic on, which means it basically is not part of the physics system, but if we turn the kinematic to off on this, and I hold space, both thrusters will fire, which is why we go off diagonally in that direction over there. And the reason they both fire is because right now, we have that bound to, like, directly bound to keycode.space, which is what we're going to be modifying today. We're going to make it so that you can assign different hotkeys to each thruster. That way, all of a sudden, you've got a much more controllable ship. This is going to involve, I mean, strictly speaking, I guess it's all user interface stuff, but about, like, 3 different user interface stuffs. The first thing, obviously, we've got to get rid of this hard coding for the keycode space. Now, again, as I explained in the recent hotkey tutorial, or standalone tutorial, what we can't use is the Unity input system. I mean, we're going to use input.getKey, but I can't use input.getButton with like a string for a button name. Normally, we'd be quite happy, depending on what kind of game, to be able to go edit, project settings, and input over here, and defining our inputs this way. The problem is that you can't change these at runtime currently. There's something that the Unity people are working on and have been working on for a while, but right now we can't do that. So we'll have to implement our own system, which is fine. It's quite easy to do. Basically, what we're going to have is this key code here. We're going to make sure we have it as a variable. Do I want to do it as a public? I guess maybe not. It doesn't, I don't think it really matters, but I guess we'll have something like a protected key code like this. And I mean, I suppose we could have a getter and a setter or different things. Let's just start with this and go with it. So the idea is this is the key code that we're going to use over here. Now, key code, just like vector3 and a few different things, is a it has to point to a value. It's not a reference thing. Like, I can't set it to null. If we do this, we'll actually get an error right here, because it's a value type. It can't be just a null. It always contains something. The default thing it contains, which, I mean, we don't have to do this, but I'll make it explicit, is keycode.none, basically the same as a null. So presumably, input.getKey, if the key code is keycode.none, it'll never return to true. It's actually, and you know what? Let's just verify that it doesn't actually just throw an error or something like that. So if I go and put the thruster on here, and then turn kinematic off, and then hit any key, yeah, it's not resulting in any kind of error, but oh, I was like, how is it moving? Right, WASD is bound to camera movement. Okay, that's fine, no problem there. So that's good. So what we have to do is some sort of system to allow us to change what this key code is based on some sort of interface. So what we're going to want is we're going to want some sort of in our canvas here, or in UI, we're going to want some sort of window. I'm going to create an empty to start off with. Actually, that's not true. What I'm going to do is create a image. I mean, I could have made an empty and then added the image component, but this is going to represent the background of our dialog box. So this is going to be the, I don't know, I guess this is going to be the component, can't see with the mouse in the way, component keybind dialogue. There we go. Component keybind dialogue. It's going to be something like this. We'll set the sprite to one of the nice background ones, which has rounded borders and is a little bit darker over here. The window doesn't have to be very big. I'll just like do something like that. And it's currently set in the middle, which is all right. I don't know. I feel like it just should be a little taller. I have no idea why. It just feels like it'll look better. At some point, you'll probably want to come up with some more standardized way to do your dialog boxes, maybe use some sort of proper graphics so that you've got cool looking title bars and stuff, but for us, this is going to be okay. All right, what we're going to do is inside of this, we're going to add a text for, like, this is just going to be the dialog title. It's going to be something like, set keybind, I don't know, we'll call it the rebind there. We'll put that in the top left corner. I mean, I guess it doesn't strictly need a title. We could have just done something a little bit more minimalistic, but that's okay. So we'll just put it over there. That's going to be okay. All right, so what's the actual work going to do? The actual work is going to be something like, I guess we still need one more text label over here, which is going to be, I don't know, keybind, boop, like that. And then in our UI tutorial, we did put a button in here that you had to click first. We might still want that, or I'm not sure actually. I guess as long as this window is open, that's how we're going to do the rebinding. So what I'm thinking in my head is something like, if you right click on the thruster, this window will come up, and then you'll be able to hit a key to rebind it. And I guess that means we're gonna have to go and perhaps put in a button to close this window, you know, in case we change our mind, or at least we're done with the window. So we'll just go and relabel this to something like an X, boom, like that, and resize it to be square, and yeah, it's bound over there. All right, it's not the prettiest window there is, but it's fine. So that's just a generic label, but the most important one is probably one more text. And again, this could be a button or it could be anything. I guess I'll just move it manually over here. That's going to be okay. And this is going to be labeled to be like, I don't know, keybind, something like that. And so what it's going to look like in the end is something like space, right? This is going to be the actual text of the key that is bound to this particular thruster for now. We can make this improved a little bit later. So we've got this whole sort of mechanic. And then we have to choose, like, who does the work? How does this open? And while this window is open, how are we listening for things? And I think that's exactly what's going to happen. I think what we're going to do is we're going to make a new component. I'm going to make a new script in C#. I'm going to call it component keybind dialogue. And what's going to happen is, if this can open up, maybe. I did double click on you. Let's try again. There we are. All right, component keybind dialogue. What I want to do is, like, while it's open, while this window is open, listen for a key press. And then what we want to do is update, like, the base component and tell it to change its keybind. So right now those are all thrusters, but you know what we'll probably do? Is I'm thinking, just for future proofing, we'll assume that there may be things other than just thrusters that we want to keybind later on. For example, maybe we're going to want guns or other types of things, you know, that you can toggle or do whatever, you know, turn lights on and off. So I'm going to create a new base component over here called something like keybindable component. Yeah. I mean, it's really wordy, but that's okay. So we're going to open that up, and what we're going to do is we're going to make it so that the thruster is actually inherits from keybindable component over here, and this key code is actually going to be part of this over here. Yeah, that's going to be okay. So thruster can still use it because it's protected, not private. So the children of keybindable component can still interact with this and do various things. Maybe we'll want better encapsulation later on, but if I think for now it's going to be okay. And so what we want is we're going to need at the very least probably something like a public void set keybind. So, and that's going to take in a key code. Now, of course, we could use properties, you know, with getters and setters and different things like that. But I think this is going to be okay. Really, well, actually, getter and setter may make a lot of sense now that I think about it. And the reason I say that is because our dialog box is going to have to read that. So, you know what? It's probably okay. I'm going to change this to say public. And I'm going to get rid of this because the default is actually fine. The get is going to be public, but I make the set, hell, maybe even private set. There we go. So that's going to be okay. Although, yeah, then I can't set it from outside the thing. Do we need to do validation for the set? Well, I guess we could do the set over here. Okay, we'll just make it public, getter, setter. We could always override these behaviors later on if we need to do some sort of sanity checking. But for now, that's going to be okay. All right, so let's see. We've got that. So our component keybind, when it opens up, it's going to need to have some sort of... It's going to need to have a public void. I'm going to make like a open dialog function, and it's going to require that you pass it a keybindable component. KC, although I'm using that for keybind as well, but that's going to be okay. And we're going to keep a reference to that. Keybindable component. There we go. We'll do that. We'll do this, and we'll do this. Oops. This dot that is equal to that one over there. And what this is going to do is it's going to set active GameObject.setActive true. There we go. That's going to be fine. So to open the dialog, you run this, you do this, and it sets active for you over here. The mouse manager is going to be responsible for that. So basically, the mouse manager is going to have a public reference to our component keybind dialog. Because the component, come on, autocomplete, don't be stupid. Component keybind dialog, there it is. Because this component is going to start non-active, we won't be able to find it at runtime, which means it's going to be important for us to set it in the inspector over here, create the link. And then in the run over here, we're going to change the code around a little bit. In our update, what we're going to do is we're going to add a void check left click. We're going to split them up. And this isn't necessarily the best way I want to organize this. We'll probably do some modes. Well, this is going to be fine. So basically, over here we've confirmed that the left mouse button has been clicked down. So what we're going to do is take all the code that happens when the left mouse button gets clicked down and just move it into here. So that's going to be one set of behaviors. And then another one, and I mean we could do an else, but I don't think it's important, is going to be get mouse button down 1, and we're going to make one called check right click. There we go. Nice thing about this is it keeps your function a little smaller. It's always a good idea. I keep saying this. If your functions get too long, and this one's not actually that long, it could all fit on one screen, despite the fact that I've like zoomed in a lot, which is usually my thing. I want my functions as much as possible to fit on one screen. Because of all this comment here, we don't quite fit it all in, and also I'm way zoomed in, so you'd be able to fit a little bit more. The advantage of keeping a function short enough to fit all on one screen is it's easier for you to see all of it at once and understand what's going on. So anyway, and also your function should really be single-minded over here. So yeah, this is just right-click behavior. Left-click, what we'll do later on probably is some sort of mode check. If we have multiple modes, then inside of left-click we'll say, okay, well, are we in this mode? Yes. Okay, then you're going to run this other function, which is going to be like place object, right? Spawn cube kind of behavior, which is this. So we can keep sort of breaking this down further and further as we need more subdivision. But for now, what we're going to do is with check right-click. Now, it's important, my right-click already does something, right? Right now, in this part of the camera, if I right-click and drag, it rotates my screen, which you can't see as well because I've got this window open now. But there's that behavior. Now, I'm still okay with having the mouse movement or the camera movement code to be entirely within the camera script, despite the fact that it is mouse stuff, and maybe that's the mouse manager's role. But what we're going to do in here is with check right-click. What do we want to do? Well, there's a couple of different ways. Instead of get mouse button down, we could check on mouse button up. And what we can do is when the mouse button originally goes down, all we can do is like track the mouse position. And then when we release the mouse and we get a get mouse button up, we can see if the mouse position has changed. If it has, then that means we've been dragging the screen around, and therefore maybe we don't want to do a to open the dialog box. But I guess for now, we'll just go ahead and just assume if you right-click down on something, that's going to be fine. So again, we're going to do a raycast. So probably what it makes sense then is for us to do a bit of code here that is something like returns a collider, perhaps, which is going to be something like we're going to have do raycast. Right? Because all of our raycast code is pretty straightforward over here. So it's going to be something like this, do raycast. We're going to hit something, and then what we're going to do is we're going to return the hit info dot collider. Now it's worth noting, this is something that came up in a recent email that someone had sent me. Hit info dot collider always returns the collider that the raycast hit. You know, even if that's an object that's buried deep in a hierarchy. But there's kind of a quirky behavior. You can also do a return hit info dot transform. Now, normally, or a lot of the time, hitInfo.transform will point to the same object that hitInfo.collider does. Obviously, this will return the collider component of that object. This will return the transform of that object. But in theory, if you then went .gameObject and .gameObject, you would end up at exactly the same object over here. But there's a gotcha. If that object, like our ship, right? Our ship here The ship root here has a rigid body, right? So we're going to have things nested deep inside, like one of these snap points. So normally, if we did not have a rigid body on the ship root, then, and we clicked on snap point, then in that case, hitinfo.transform.gameObject would return the snap point itself. But as soon as you have a rigid body in the hierarchy, the hitinfo.transform.gameObject, this actually points to the object that the rigid body is on. And basically, what it means is you can also do hitinfo.rigidbody, right? So you've got sort of these three ways. I mean, you could ignore the .gameObject part. That's not the part that's doing the real work. But there's three ways to find out from info what did we hit. The collider always returns the actual collider no matter how deeply nested it is, which means the .gameObject is going to be something like, you know, way inside. If you're talking about array that collides against a humanoid, this might point to like the belt, right? If the belt has its own collider, then this GameObject will be the GameObject of the belt. And if there's no rigid body on this, you know, this human being, for example, then transform.gameObject will also return just the belt, and rigid body will be null, right? If there's no rigid body on the object, then hitinfo.rigidbody will be null. But if there is a rigid body on, say, like the root of the character, then collider will still return the belt, but both this hitinfo.rigidbody.gameObject, this will return the base humanoid, which makes sense because that's where the rigid body is, but the transform will also return the base humanoid. So a bit of confusion there. You actually got a couple of emails about that because people are using .transform, which is fine, but it can lead to kind of a funny thing if you add or remove rigid bodies. So for us, we're just going to return the actual game object that we hit directly because that's what we want to do in this particular context. So what I can do is just tweak my code a bit here just to reuse some of it. So what we're going to do is instead of using hitinfo.collider, because we don't need the hit info, anything else from the hit info in here. Yeah, that's good. We could also, from this code, I could return the hit info itself. Right? That would also be a fine alternative. But I think, well, actually, let's do that. If we hit something, we return the hit info. If we don't, we'll return null. And that's going to be okay. So this is a raycast hit. Like that. Which I don't think is a value. So doing this is okay. No, it's a value type. So we can never technically return null. All right. Return the collider. That's going to be okay. And then we'll figure it out. So we've got this. In our left click, what we're going to do to use this shared function. I'm doing this because we're going to use the raycast somewhere else as well. So we're going to get collider. The collider is equal to do raycast. If the collider is equal to null, then we didn't hit anything, so we can just abandon the left click completely. Otherwise, what we're going to do is run some code. Now, I'm going to get rid of all this, because that's all the raycast stuff, which means then we can go and bring this over to the right, or the left, get rid of this extra little thing over here, and we're just going to change everywhere it says hitinfo.collider, we're going to replace it with the collider. So that's the collider we hit. And by doing this, we get to reuse some code. And that's always quite nice. There we go. So that's back to working the way that it was. And in right click, it means I can go ahead and do also grab a collider to see if we hit anything. If the collider is null, then we just return don't do anything. But if we get to here, we have right clicked on something. Is it or does it have a component keybind dialog? Now, the problem with this is the thing we clicked itself, the thing we right-clicked itself, might not have the component keybind dialog because if we look at our thruster, let me hide this window here. Let me hide this. Or sorry, it's not component keybind dialog. Is it a keybindable component is what I actually mean. Is it a boom? Oh, by the way, I went and made this as a subclass, right? So thruster inherits from keybindable component. This could have also been done as an interface, which may actually be a more suitable way of doing it, but it's going to be, makes really no difference at this point. So is it a keybindable component? Now, of course, I mean, the easiest way to check that is just to do something like keybinding component, KC is equal to the collider dot get dot game object dot get component, like this. And even though we don't add keybindable component directly, we add thruster, but because it descends from that, this will return that. And actually, that's one thing I'm not sure about with the interface. I think it might still work with the interface, but this will work and will return something that's either, you know, null or not null. The problem is that the thing we're clicking on may not have the component. And again, this becomes very obvious. If we drop the thruster in here, right? What are we going to be clicking on? When we right-click, we are going to be, let me move this over so that we can actually see what the hell's going on. Also, your size is all whack. Oh, yeah. Thruster. Let's just do this and then add you to the snap point. There we go. And not the zoom. We want to move you. Actually, no, we don't have to move you. Okay. So the thing we click on, it's going to return the collider, which is on the graphics layer over here. Whereas we have, well, the thruster script is on the base object itself. Now, I could move the thruster script onto the same object that has the collider, but that starts to feel kind of wrong and weird. And then if you replace the object and the collider, then you have to remember to replace the thruster script, which seems kind of odd. To me, it makes sense that the thruster script should be on the base thruster object itself. But again, at this point in our code, in our right click, the collider that we hit on is actually going to be this over here. It also becomes a problem like that if, for example, if it had a snap point, which the thruster doesn't, but a good example is the cube. The thruster, it's possible that we right-click on the snap point here, right? We might right-click on the snap point, and it's not going to have the thruster component or the keybindable component. It's going to be the thing it's attached to. I think, given our overall structure we're going with, it's actually going to be 100% fine for us to just check the parent, right? Because it's always going to be the parent of whatever we right-clicked that's going to have the keybindable component, given our current code structure. That might not always be true, but for now it's an assumption that we can make, but, you know, be on guard for that. So, what we're going to say is we need to check the parent of the object with the collider, given how we have assembled our prefabs. So we're going to have transform the parent. I mean, again, I'm being extra verbose, but, you know, it's not necessarily bad. So the collider has a transform, has a parent. If the parent is equal to null, we clicked on something that doesn't have a parent, so it's probably not a valid part of our ship. Maybe, maybe not, so we'll just return at this point. Then what we're going to do is we're going to get the keybindable component from the parent and say if keybindable component is equal to null, then this object isn't keybindable. So there's that. There's another way we can do it. What we could do with all of our ship parts, and this actually might be a safer way of doing it. All of our real ship parts, we might want to have tag. We might want to create a tag for ship part. And all of these guys, we might want to set ship part as their tag. So they're all tagged with that. And what you could do is you could go up the hierarchy. In case you end up like, what if you end up with a model where the collider is actually buried like 3 or 4 layers down from the proper ship part component? Well, then what you could do is you could put in a code that says find attached ship part, which is pretty easy to do, and maybe we should do that. So something like this. So we're looking for a game object, just per se, that is the so find base, or find the ship part from a collider, right? So we pass it a collider, and we want to find the game object that is the actual ship part from here. That's pretty easy. So we can do something like, we set a transform for current. So the collider's got a transform, right? And then we say something like, while cur is not equal null. I mean, it won't be on the first one, but that's fine. We can do a check that says, if cur dot game object dot layer, no, sorry, not layer, tag, which is a string, if it's equal to ship part with a space or not. No, one word. If this current object has that tag, then what we can do is return cur.gameObject. Otherwise, we set current to be equal to its own parent. So we're going to go up the hierarchy until we find something that's either tagged with this, or we run out of parents, at which point we return null. So this will tell us the actual ship part that we clicked on. And that might be much more reliable, right? So maybe we'll do something like gameObject ship part. And for this, what we do is we say, hey, why don't you find the ship part from the collider, which is the collider. And then if ship part is equal to null, then we didn't click on something valid. Otherwise, we'll get the component from this. This object's not key bindable. So if we get to this point, we have right-clicked on something key bindable. So what we're going to do is we're going to say we've got our component. What's it called? Component keybind dialog. We've got this, and we want to say open dialog, and we're going to pass it the ship part. Sorry, not the ship part. We're going to pass it the key bindable component, like that. Boom. So we've right-clicked on it, so we're going to open the dialog box with that over there. Okay, so back to our dialog box. What we are going to want to do is we need to make sure to label it properly, right? You're recompiling. Let's go ahead and make this active again. So this little spot here where we've got the keybind, where it says space, we want to make sure that it gets labeled properly. So we want to find in our children, we want to find a child that has the name of keybind. So that's fine. Copy and paste broke, so we're going to use the find trick over there. So in our transform, find a child named Keybinding, and it has a component of type text, although we'll get an error here because I have not yet included using Unity engine.ui. There we go. So now we know how to interact with text, and then we want the actual text part of that text class to be equal to the keybindable component dot keycode. I don't think we have to do a toString, but we might have to. So there we go. So now when the window opens, it will go and set the keybind to whatever the correct text is. So instead of saying space, here, what I'll say is, I'll just put a bunch of X's in here as a placeholder so that we can see that it works. So I'm going to take this dialog box, I'm going to hide it. In our scripts over here, our mouse manager needs to know what the component keybind dialog is. So we need to make sure to drag this over here. Oh, I never added the script to our dialog box. So now that should work because our component keybind wants something that's actually got that component on it. There we go. So we got this. So now if I hit play and I right click over here, I was going to say nothing should happen. Because the root, oh, it's not keybindable. We have to return. There we go. We were trying to open up the keybind dialog box for the root node, which doesn't actually have this component on it. So we're getting an error there. But it shows that most of our code is working. Let's try it again. So now if I right click, correctly nothing happens. If I put a thruster here, and then I right click on this, the dialog box will open, and it will tell us that the keybind is null, or none, right? As opposed to all those X's, because currently this doesn't have a keybind. So that's great. So now we just have to get the actual part that makes it a keybind, which is really easy to do. So update only gets called when the dialog box is active. Otherwise, it doesn't run. So while it's active, what we want to say is, hey, input system, was any key pressed down? Not like currently down. Was any key pressed down since the last frame? This simply returns true or false. So if this is true, we have to say, okay, which key was pressed? And there's no way to get this because it's entirely conceivable that more than one key went down. So you can't just ask the input system like, well, which key was it? Because it could be more than one. So you sort of have to like, you know, what context you're working in. If there's more than one key pressed simultaneously, we're just going to grab like the first one we find and call that the keybind because that's the sort of system we're looking for. So what we need to do is we need to iterate we need to loop through every possible keybind. Now, the key code is an enum. So we can loop through each enum possibility, which is what we're going to do. But to do that, we have to make sure to using system over here. Well, I mean, we don't have to. We could type it out the long way. But by including system over here, it gives us access to the uppercase E enum. Normally, we don't have that. And this has some static functions that are really nice to work with. For example, get values, which requires that you pass it a type. So type of, and then spell it correctly, type of key code. Okay, so we pass it the type of key code in here, and this will return a list of values, which we could iterate over. So we could do something like for each key code in these values, then we can do a loop if we put in the correct number of parentheses. There we go. So now we will loop through each possible key, and in there we're going to say if input dot get key, goddamn spelling is hard, get key down key code. Right, so we're looping through every single possible key, finding out if that was the key that was pressed down. This feels very, you know, non-optimal, and I guess in a certain way it is, but this actually runs very fast, and it only happens when this window is open, only if any key has been pressed down. So it's actually like, it's microscopically fast. No problems there. If this was pushed down, then we found our key. We found our key. So what we want to do is we want to tell the key bindable component that its new key code should be this key code we've just found through looping. Then what we want to do is we want to close our dialog box. So we're just going to say gameObject.setActive to false. And then we can just like return and break out of this loop. So this will close our window. Boom, done. So let's give that a try. If I go and hit play, I'm assuming we've done it right, and say I add a thruster over here. Now, let's say I turn kinematic to off. So now I try to hit any keys. Like if I'm hitting the space bar here, nothing is happening. But I'm going to right click on the engine, and then I'm going to hit space bar. The window will close. And now if I hold down space bar, nothing is happening. I thought it would. Okay, this clearly worked. Right click. Whoops. Oh, right. So on my mouse, I'm going to hit my right mouse button, which counts as a key. So if I open this again, you can see it's bound to mouse 1. Why isn't it moving, though? Okay, two things. First of all, we want to ignore the mouse clicks. If maybe, like, we're going to loop through all the key codes, but if, as long as key code is not equal to keycode.mouse0, and it's not equal to keycode.mouse, not equal to keycode.mouse1, and it's not, it's kind of a little awkward, but I'm not sure. I guess what we could do is like, we could set up an array of like not allowed keys and then iterate through that or something. I guess it's gonna be fine. And keycode is not equal to, I'm just gonna put in mouse 2, which is the middle mouse button. We're gonna ignore the others. If someone wants to bind like their thumb button on their mouse to one of these, that's gonna be okay. But we're gonna ignore left, right, and middle mouse button in here, which is going to avoid some funny little behavior. So again, I'm going to put a thruster here, right click on here. So there you go. I'm clicking my mouse buttons and it's not using those. If I put in space, then that closes. But when I'm hitting space, it's not actually using the behavior. Why is that? Why is that? Because we did change. We clearly changed the key press, because if we right click on this again, you can still see that space is in there. Oh yeah, the X button doesn't actually do anything. We'll wire that soon. And the reason the X or the space bar shows up in the text is because the key bindable component's key code gets set to a string, and that's this key code here, which should be what the thruster uses. Right here. But it's not. Is it? There's just probably something really obvious that I'm missing, but we'll deal with that in a second. So, thruster goes there. Turn kinematic to off, and it's checking none, 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 none. I'm going to right click, hit space. Oh. Now it's working. Did I? Oh, it's possible I never saved the changes to one of the script files. It's possible that's what happened, where one of my files hadn't been saved, so the changes didn't take effect. Because it sure as hell seems to be working now. Oh, also, hold on, that's going to lead to some confusion. And that might not be helping. We do have that extra thruster that was still on there. Yeah, why was it going sideways? So let's try this again. I'm going to put a thruster on the side. I'm going to right-click, tell it to bind it to space. Turn kinematic off, hit the space bar. There we go. Interesting, the center of mass is slightly off. But I'm actually wondering if it was working before and the two were fighting. Why is the center of mass slightly off? Thruster, add you here. Turn kinematic off. You should be going straight to the left. Okay. Oh, you are going straight to the left. It's the camera angle that's going funny. Okay. It looked like it was turning, right? It wasn't just me, right? It looked like the thing was spinning a bit. It's the camera angle was a little bit funny. I guess it would be a lot clearer if I hit... I've put a thruster on the front part over here. Turn kinematic off. Oh, and rebind this to space. And now hold space. Vroom. There we go. Excellent. Now, there's a funny little behavior in that because it works if... whenever the key is held down, there is actually this slight moment where the actual key, when you hit the key to lock it in, it actually activates the thruster at the same time. I think it's like almost needs a little bit of a cooldown before it takes effect or something like that. Give it a chance for the key to go up. How do we want to do that? Actually, that's a good idea. That's just the way I'm going to do it. Oh, it doesn't have an any key up. That's kind of stupid. Because I kind of want to only respond when the key goes up instead. Why is there not an any key up variant? Unity, come on, you're killing me. I mean, we could track that pretty easily. But you know what? Again, this is not particularly like hard on the system. If I just comment out that check and say get key up. So we're actually only going to rebind when the key is released. That'll avoid that funny little behavior of the engine like going on the first click. So I'm going to put a thruster there. I'm going to keybind you to space, which actually wouldn't have shown anything anyway. So again, I'm just going to hit space now. Okay, now it's going because, right, it still had the keybind. Oh, well, that's something interesting. I'm putting the thruster. Click it there. Turn kinematic off. So right now, nothing happens. I'm going to right-click, push down space. Nothing's happening. As soon as I release space, it binds the key, which closes the window, and now I can push the space to get it to go again. I mean, we can tune that. You know, that's the sort of thing that you can fiddle with to get it to work, like, just right and in a really slick way. But we do have bindable little thrusters now, which means actually if we go and do a slightly better example of this, let's say we make this a little bit bigger. Let's just use a 4 set of cubes here. That's going to be fine. So there. That's going to be okay. And let's say I add a thruster here and here, and there, and there. Actually, you know what? We have to get all of the thrusters to ignore key presses while this is open. That's actually going to be our real solution. Because what I want to do is on this one here, I want to say left arrow, I guess, because it's actually going to send it that way. And over here, I want to set it to right arrow, which I just realized is also bound to the camera, so this is going to lead to weird things. Up arrow, up arrow. So now if I hit up, yeah, the camera's moving, which is weird. Actually, why aren't these responding to the arrow keys? They're not. Like, nothing. The only reason we're getting movement is because the camera is moving, but the camera shouldn't be eating that input. Let me try you. Yeah, again, okay. There's something funny when there's more than one engine in place. It's not doing it. What is going on? Where's our bug here? It's clearly getting the keys, but again, is it doing it for all of them? Is there something bizarre going on there? Let's see here. Let's have it debug.log right here. what is going on? So close, reopen. So with one thruster, it's fine. Put it there. Assign you to, I don't know, U. And turn kinematic off. Oh, maybe I forgot to turn kinematic off. That's probably what happened. Hold on. I'm probably just being a derp. We probably need some sort of visual indicator that we're currently in edit mode as opposed to driving mode. So do that, do this, and then we want to right-click here. So that's going to be the H, the K, the U, turn kinematic off, and now, there we go. And then turn, and then go, and then turn this way, and come back. Whoop, 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 you can do it. There we go. We have a vaguely steerable ship, but not really. Actually, one of the ways to get the ship to spin a little bit more controllably is to, so let's say we had cube. You want like sort of a sideways thruster here and here that are both set to say like H and H. Then we turn kinematic off. And there we go. So now it twists that way. Because with just one, instead of sort of rotating this way, it was just sort of like leaning in one direction. But there we go. And then we can turn kinematic back on. And then we can apply more thrusters, say there and there. And then set you to K, and then thrusters here and here. You're going to both be set to the U key. Turn kinematic off, go forward, turn around, try to rest that, and then push back over here. There we go. There we are. Vroom. Whoa. Oh. And then I lost sight of it. There we go. And you know what? I think I'm a little bit backwards with my left and right. I should have done it the other way around, but that's okay. I'm trying to bring it back in front of the camera. There it is. Whee! Vroom. There it is off in the distance. Come back. Okay. Come at me. There we are. Vroom. Excellent. Whee! Actually, you know what? This top-down view, this might be a way to go. It actually looks way more entertaining this way. And a little easier to see what's going on. Now, you can limit the top speed of these objects, the top rotation speed. I mean, they're actually already limited by the base system. If you go to... So if you had a copy of the rigid body, right? So, rigid body, R. And you had this, there's a maximum angular velocity, which is how quickly you can spin. I guess there's not a maximum velocity, period. Although you can fix that yourself, right? If you take a look at the velocity, you can, like set it to a new variant. Like if the magnitude of this is too big, then you can just overwrite the velocity and force it to never go faster than blah, which is a common thing to do in games, even, in space simulations where there's not supposed to be max speed in space, but it turns out it's kind of a pain in the ass to drive something that doesn't have a max speed. While it's more realistic, it doesn't feel intuitive. The other thing you can do, and this is super not necessarily realistic in space, is you can add drag, which effectively will give you a maximum speed because this is basically like just sort of air friction that's slowing you down. Now in space, there's not much air. Technically, there always is. Like the International Space Station is actually in an orbit that's such that it needs to be boosted quite frequently because while the air is incredibly thin, I mean, from the human perspective, it's effectively a vacuum, but there's enough there to continuously slow down the ISS. In fact, they even position their solar panels in such a way to minimize drag, especially when they're on the night side of the Earth, right? And they're sort of eclipsed by the Earth, so the solar panels aren't doing anything. They can be in a particular orientation so that they slice through the air that's up there, so that it is as less as possible. And apparently by doing that, they save like, I don't know, thousands of tons worth of fuel over the course of, a year or whatever it is. I don't know how much it is, but it's pretty significant. So, so drag is technically not unrealistic in space, especially if you're not in deep, deep space. But more importantly is a very, very functional way in gaming terms to limit the top speed, as well as if you're not thrusting, it'll slow you down, which actually tends to make things a lot more controllable. Like, let's say I set my angular drag to something like 1 instead of 0.5, right? We hit play on this again. I should have like a shortcut to like quickly build these models, but that's okay. Thruster here and link you back both to the same key. So U and U. Turn kinematic off and then hit you, and then I'm letting go, and you see how it starts to slow down? Now, an actual object in space will not slow down like that, right? But it sure as hell feels better and is more controllable. Because then you don't have to worry about like, oh my god, I'm spinning, I've got to apply reverse spin to slow down quickly enough, and trying to figure out like what the correct direction is. If you just, you know, have that drag, that's good. And again, you could have, that's angular drag, which is stopping spinning. And then the regular drag is going to be to stop sort of forward motion. And again, with the same thing, it makes it inherently more controllable, as well as a side effect, actually providing a maximum speed. Altogether works out pretty nice and just feels better, even though it's not super realistic. But anyway, we finished our simple little user interface. I might do a little bit of behind the scenes work to make the dialog box look a little bit sexier. I'm not sure, but hey, we're well on our way to a game. Thanks for watching, folks. See you next time. Thank you to all our September patrons, i.e. people who've pledged in September and are supporting the videos from October to early November, and especially these Mike Check supporters. We've got Yuko Finn, Ole Peter Talgo, Adam Conway, Drazian, Jan Torrevel, Adjective, Michael McClintock, Aaron Doibson, Craig Mortel, Stephen Wendell, Julien Auger Lafont, Marius Fieldvold, Speedy Savant, Stephen Stager, Valiant Cake Fiend, Wes Olenboving, Jason Yanity, Kale the Quick, Neil, Blakey, Milner, and everyone who's watched, shared, favored, and subscribed to the series. Thank you very, very much.